For 40 years, the Pacer name has been synonymous with quality and centrifugal self-priming pumps. In fact, the self-priming pump was developed and patented here at Pacer 40 years ago. Professionals working in agriculture and construction know that when they purchase a Pacer pump, it's going to be a reliable piece of equipment for years to come. The self-priming centrifugal pump is a general all-around, all-purpose pump. It is of simple construction with few wearing parts, is therefore economical to operate and maintain.
We're going to walk you through some of the key factors that make the Pacer pump such a valuable tool for the workers who rely on it, as well as discuss the best practices for operating the pump for reliable and consistent results.
The centrifugal pump is one of the simplest and most efficient of all machines. It consists of a set of rotating vanes enclosed within a housing. The vanes, which are called the impeller, are there to supply the energy to the liquid by centrifugal force. The housing that contains the impeller is called the volute. The remainder of the pump consists of the inlet passage, which leads the liquid to the impeller, a discharge passage which leads it away, a seal on the impeller shaft to keep the liquid inside the pump and the air outside.
The standard centrifugal pump does not have air handling capacity. As a result, unless the pump can be located below the source of supply, there must be a means of filling the pump casing and the suction line leading to it. This is called priming the pump. The self-priming pump was developed to avoid the need to manually reprime.
Self-priming is especially important in construction areas where the pump is used in low seepage areas. Under these conditions, the standard centrifugal pump can only operate until the entrance of the pipe is uncovered. Once the area becomes uncovered, it becomes airbound and can't reprime itself, even when water returns.
While many ways have been developed to make a centrifugal pump self-priming, the most general way is the recirculation method. Such a self-priming pump contains a water reservoir, either attached to or built in the casing of the pump. It is necessary to fill this reservoir before the pump is to be started for the first time.
The recirculating port is provided in the reservoir. The port is designed small enough so it cannot feed the impeller more water than it can handle. Consequently, as the impeller turns, it takes all the water that comes through the recirculation port, and in addition, will draw a certain amount of air from the suction line. A mixture of air and water is discharged by the impeller into the water reservoir. There, the water and air bubbles separate, with the air passing out through the pump discharge and the water returning to the recirculation port to remove more air from the suction line. This continues until all the air is removed from the suction line, and the vacuum produced pulls more water from the suction supply line into the impeller.
When you first use your pump, you'll want to inspect the unit to see that no parts were broken in shipment or are missing. A pump instruction sheet and parts list, an engine instruction sheet are all supplied with each unit.
Fill the crankcase with high-grade oil as specified on the engine nameplate or the instruction book, and fill the fuel tank with fresh gasoline. Provide the necessary space around the pump for inspection, servicing of the unit, and adequate ventilation.
Set pump on firm footing and make sure the pump will not move due to vibration. Place the pump on boards or a hard surface or on Pacer's optional roll cage and not in the soft mud. Pumps improperly placed have been known to fall into the excavation when the suction line was full of water. When first installed, it is necessary to fill the pumps with liquid in order to provide the initial prime. It is not necessary to fill the suction line. To give the pump its initial prime, first remove the priming fitting in top of the pump casing. Fill the pump casing with liquid, replace the plug, and then start the pump. The shorter the suction lift, the faster the pump will prime. Never restrict the inlet or outlet on initial startup. After the first priming, the pumps will retain sufficient liquid for proper operation. Make sure that the hose used on the suction does not have a collapsed liner or any breaks, cuts, or pinholes in it. An air leak will prevent priming and will reduce the capacity of the pump.
A size larger than the pump's connections will increase the capacity of the pump under low heads, but will decrease the speed of priming. When using rigid piping, proper independent support should be provided for the piping. It should not be supported or carried by the pump. It is advisable to install a short length of hose between the pump and pipe on both suction and discharge. All piping, and especially that on the suction side, should be made as short as possible with the fewest elbows in order to avoid unnecessary friction loss.
The hose on the discharge side may be of the collapsible type or the rigid type. Again, make sure that hose and fittings are in good condition. It is not advisable to use pipe sizes smaller than those for which the pump is fitted. On the other hand, in order to maintain a high capacity, larger sizes may be advisable in some cases.
A proper strainer must always be installed on the suction line. Otherwise, the pump may be damaged and become clogged and its capacity reduced if not stopped. The strainer should have a net area of at least 4 times that of the suction pipe and should be inspected and, if necessary, cleaned at more or less frequent intervals. Self-priming centrifugal pumps may be located as high as 25 feet to the suction inlet of the pump above the source of liquid. It is, however, good practice to keep the suction lift to a minimum. 15 feet is ideal.
It is best if the suction pipe has a gradual rise towards the pump. While this is essential with a regular centrifugal pump, it is also best practice with a self-priming pump. On long discharge lines, the discharge pipe should be one size and sometimes 2 sizes larger than the discharge fitting of the pump in order to decrease friction loss. The length of the line, number of bends and fittings, together with the quantity of liquid to be pumped, should be taken into consideration in selecting the proper size of pipe.
2 discharge lines may be used. On high head jobs, a check valve should be installed in a discharge line close to the pump. A check valve is required to protect the pump against excessive surge of pressure from a vertical discharge line.
Self-priming centrifugal pumps are provided with a built-in check valve in the pump on the suction side. This valve comes into operation to prevent the loss of priming liquid in the pump casing during idle pump periods. A foot valve on the end of the suction pipe is not a necessity.
Should conditions require that the pump be throttled, slow down the engine when possible. However, it is essential to maintain full engine speed to prime properly.
Proper maintenance of your engine-powered pump will provide years of uninterrupted service.
The engine manufacturers recommend the following services. Drain and replace the engine oil after the first 5 hours of use and then every 50 hours or annually, whichever comes first. A synthetic 5W30 will suffice for all types of climate. Be sure to check the oil level before each start.
Clean the air filter after 25 hours of use or after use in a dusty environment. Replace the air filter annually.
You'll also want to replace the spark plug annually. Refer to your engine manual for proper plug and gap setting.
Use clean gasoline, ethanol-free if possible. If ethanol is added, use a stabilizer mix to prevent possible fuel system problems.
Allow your engine to cool 5 minutes before refueling, and never run your engine in a closed area such as your basement or garage. Carbon monoxide can be dangerous. And always refer to your engine manual for proper use to ensure your safety.
Pacer Pumps was founded in 1974 by Al Marlowe, a gentleman whose family had a long history of pump development. We remain a family-owned entity, locally managed in Lancaster, Pennsylvania, and run by the son of the third owner.
Our core business is assembly of the corrosion-resistant pumps assembled with components manufactured by Polymar, our ISO sister company. Pacer Series S Econo-Ag pumps are molded from DuPont Rhinite glass-reinforced polyester, which exhibits far superior tensile strength. This is a critical requirement in pump construction. We assemble our products with globally recognized manufacturers of engines, motors, and other drives so end users can rely on widespread warranty service where required. All gasoline engines are EPA CARB certified.
Every pump sold through your locations is fitted with warning labels, safety instructions, and installation operations manuals. These are required so that your customer's utmost safety and satisfaction is guaranteed. The manuals emphasize understanding the usage so the pump sold is suitable. This includes knowledge of the solution being pumped, environment being applied, conditions of operation, and desired results. Technical assistance is available via our toll-free phone number to assure liquids can be pumped in a safe manner, and the installation will provide long-term reliability.
We supply Teflon tape with each unit so all the ports are watertight on the discharge outlet and vacuum tight on the suction inlet. This assures speedy priming and trouble-free continuous operation. It is recommended to apply 7 to 10 wraps on each fitting prior to installation.
We assist store personnel in short-term response to special requisitions, end-user communication on problem applications, and referrals for parts, accessories, and new pump purchases.
Our company focuses long-term relationships through personalized attention. Pacer Pumps is proud of our 40 years of service into the ag market and anticipate the next 40 years to continually evolve.